This map answers one very physical question. Hang a pendulum with a magnet on its tip, and put 3 magnets on the table below. Release it from some spot, let it swing, and it eventually stops over one magnet. Color each starting spot by the magnet it ends on, and you get this.
That came from a swinging pendulum?
Which magnet wins is, in places, impossible to call. Let's build the toy up, watch it swing, and meet 3 ideas hiding inside it. Here's the setup, a bob that can swing freely over 3 magnets. Each magnet pulls it closer, while a gentle spring keeps tugging it back toward the center. And friction slowly drains the swing, so it can't wander forever.
So it has to come to rest somewhere?
Right, with friction, almost any ordinary start settles near one of the 3 magnets. The only question is which one. Watch a single run. The bob lunges toward one magnet, overshoots, gets yanked toward another, loops and weaves. Only as friction wins does it finally curl in and rest near one of them.
It wanders a lot before it picks one.
That restless overshooting is the whole reason this gets interesting. Now release 2 bobs from almost the same spot, a hair apart. At first they swing together, then their paths peel apart, and they end on different magnets. That sensitivity during the swing is the essence of chaos. The rule is completely fixed, yet near a border a hair's difference flips which magnet wins.
So you can't predict which magnet from the start?
Deterministic, yet near the borders practically unpredictable, that's chaos. So do it for every starting spot, and paint each one by the magnet it lands on. Each colored region is that magnet's basin, all the starts that end up there. The 3 resting magnets are the system's attractors, the states it gets pulled into and stays.
So an attractor is just where it ends up?
3 attractors, and a whole plane sorted by which one wins. Look at the borders between the colors. A fractal is a shape that keeps revealing new detail at smaller and smaller scales, never smoothing into a clean line. Zoom into a border and you keep finding fresh tangled detail, all 3 colors woven together, instead of a clean edge. In this system, that sensitive swinging is what makes the boundary fractal. Near it, a hair's move flips the winning magnet.
So the chaos at the edge is what tangles it?
A sensitive swing choosing among 3 magnets, and here the border comes out fractal. So this one toy holds all 3 ideas at once. Chaos, in how a tiny change flips the outcome, attractors, in the 3 magnets it settles on, and a fractal, in the border between their basins. And it's the very same story behind those Newton fractals from solving equations, no complex numbers required.
So the fractal wasn't about the equation at all?
In systems like this, a sensitive process choosing among several fates often draws a fractal map. So next time something settles into one of several stable states, picture the hidden map of where each starting point leads.
And the border is where it gets unpredictable.
A fractal border is the fingerprint of a choice you can't quite call.